Now we will be discussing ordinal and interval data. Ordinal data is a type of measurement variable that takes values with an order or ranked. It is the second level of measurement and is an extension of the nominal variable. There are two main categories of ordinal variables, namely the match and unmatched category. In the match category, we have each member of a data sample is paired with similar members of every other sample concerning all other variables, aside from the one under consideration. This is done to obtain better estimation of differences. For unmatched category, also known as the independent category, contains randomly selected samples with variables that do not depend on the values of other ordinal variables. Most researchers base their analysis on the assumption that the samples are independent, except for a few cases. These are examples of ordinal variables. Measuring using a Likert scale. A Likert scale is a psychometric scale used by researchers to prepare questionnaires and get people's opinions. For example, how satisfied are you with our service? 1 for very satisfied, 2 for satisfied, 3 for indifferent, 4 for dissatisfied, and 5 for very dissatisfied. This scale is used to gauge how likely a customer enjoyed a service. Now, for a next example is an interval scale. Interval scales measures each response in an interval of its own. For example, how old are you? For example, when people are given a questionnaire to answer from which age range they are. So how old are you? 13 to 19 years old, 20 to 30, 31 to 50. So it's not really a method to measure something, but rather a method to keep tabs of an interval. Now we will be discussing internal variable or data, which is an extension of ordinal data. For its characteristics, it is one of the two types of quantitative variables. It takes numeric values and may be classified as a continuous variable type. Arithmetic operations can be performed on interval variables. However, these operations are restricted to only addition and subtraction. The interval variable is an extension of the ordinal variable. In other words, we could say interval variables are built upon ordinary variables. But the thing about interval variables is it is equidistant, meaning all intervals on the scale are equal. So, the variables can be measured using an interval scale which not only shows the order but also shows the exact difference in the value, and an interval for data cannot have a zero value. We would see that the reason for this is because interval variables function in a way that measures only the space between two variables, not really measuring variables that are of values that can be calculated in such manners. Now, there are also two categories for interval variables, namely normal distribution and non-normal distributions. In normal distributions, it is called Gaussian distribution and it is used to represent real-valued random variables with a known distribution. This can be further divided into matched and unmatched samples. For non-normal distribution, it can also be called the non-Gaussian distribution and is used to represent real-valued random variables with known distribution. It can also be further divided into matched and unmatched samples. Now, to see how these categories apply, let us look at some examples. For temperature, temperature when measured in Celsius or Fahrenheit is considered as an interval variable because this also does not have a zero because there's no 0 degrees, there are still value in it. Next is when we are giving test scores. So, for example, quizzes or SAT, we use numbers as a reference point. And we don't really add to the scores of the students. We just measure the mean, mode, and other variables to measure the intervals of their grades. Next would be time. Now, time, if measured using a 12 o'clock or it is measured during the day, is an example of interval data. Because, like all the other types of interval data, it measures the distance of one value from another. So, and 0, it also has a value. It is 12 o'clock a.m. or midnight. Now, another example is an IQ test. So, an individual cannot have a 0 IQ, therefore satisfying the no-zero property of an interval variable. The level of an individual's IQ will be determined depending on which interval the score falls in. So, an IQ test is another example that is similar to when we are giving test scores. There are other more examples, but that would be all. Thank you for listening.